All right, let's jump right in. Ever stop to think about how you, well, think? How you learn stuff, how you remember things? It's kind of wild, right? But what if I told you that the powerful machine between your ears works a lot like the computer or the phone you're using to watch this right now? So, is your brain a computer? It's a huge question, I know. And look, it's an analogy. It's not a perfect, literal match. But wow, is it a useful one for getting a handle on how we process, well, everything? In fact, this whole idea is the foundation of a really important theory in psychology. That theory is called information processing theory, and it's pretty simple at its core. It just compares our mind to a computer. We take in information, that's the input, we chew on it, store it, that's the processing, and then we do something with it, like make a decision. That's the output. So come on, let's boot up this mental computer and see how the whole thing runs, starting right at the beginning. Okay, section 1, attention, the mind's gatekeeper. Before anything can even get processed, it has to get past the bouncer at the door. And for our brain, that bouncer, that gatekeeper, is your attention. It's the first and maybe the most important filter for every single thing you experience. Seriously, think about it right now. You're hearing my voice, hopefully. You're seeing the screen, but you're also probably feeling the chair you're sitting in. Maybe you can hear a fan whirring in the background or see something out of the corner of your eye. Your senses are just getting bombarded with information. Attention is what lets you focus on me and tune all that other stuff out. It's the process that says, okay, this is important. Let's process it. Everything else? Just background noise. So what's the real difference here? Well, without attention, all that stuff, the fan noise, the feeling of your chair, it's just gone. It passes by without you ever really noticing. It fades away instantly. But when you pay attention to something, you're actively choosing to pull that piece of information out of the noise. You're bringing it into your conscious mind. And that's what gives it a shot at actually becoming a memory. It's the all-important step 1. All right, section 2, the 3 memory systems. So, once a piece of info makes it past the gatekeeper, past your attention, where does it go? It enters the hardware, the actual memory systems. And it turns out we have 3 different but totally connected systems that manage all that data. And this is the path it takes. First stop, sensory memory. This is where everything lands for just a split second. It's like a super brief raw data capture. Then, remember our gatekeeper? Attention steps in, grabs what's important, and shoves it over to our mental desktop, which we call working memory. And if we work on it enough there, it can finally get filed away for good in our long-term memory. And this is where that computer analogy gets really good. Check it out. Sensory memory, that's like the input buffer on a computer, just grabbing everything for a millisecond. Long-term memory, that's your hard drive. It's massive, practically unlimited, and built for the long haul. And that one in the middle, working memory, that's your RAM. It's super fast, it's what you're actively using right now, but, and this is a big but, it's also really, really small. So let's zoom in on that mental RAM for a second, our working memory. This is where the real action happens. It's not just a holding pen for information. No way. It's your brain's active workspace. It's where you're juggling ideas, solving problems, and basically making sense of things in real time. You know, like when you're trying to do math in your head or keep track of a fast-moving conversation. But, and this is the big catch, that super powerful workspace is also ridiculously small. For most of us, it can only hold about 5 to 9 things at once. That's it. Ever walk into a room and completely forget why you went in there? Or someone reads a phone number to you and it's just gone a second later? Yep, you can thank the tiny capacity of your working memory for that. So how do we get around this built-in limitation? Well, we've developed some clever mental hacks. There's chunking, which is just grouping stuff together, like how you remember a phone number in 3 chunks instead of 10 separate digits. There's good old rehearsal, just repeating something to yourself over and over. And then there's the really powerful one, connecting new information to stuff you already know. These are called schemas. It's like filing a new document in a folder that's already clearly labeled. It just helps it stick. Okay, moving on to section 3, upgrading your mental hardware. Because of course, the system you're born with isn't the one you have now. It's not static. From day one, we're getting these constant software updates and hardware upgrades. Our whole life is basically one long process of refining these very systems of attention and memory. And you can really see that upgrade cycle in action over a lifetime. As infants, our attention is purely reflexive. Whatever is bright or loud gets our focus. But then, in early childhood, we start to develop selective attention. We can choose what to focus on. By middle childhood, we're actively learning strategies to remember things, and by the time we're adolescents, we're running a pretty sophisticated, almost adult-level operating system. I mean, listen to this. In infancy, our attention is pretty much all instinct. Bright colors, loud noises, sudden movements, that's what grabs a baby's focus automatically. There's not a lot of conscious control going on there. It's like the factory default base model of our mental OS. But then, you fast forward a decade and a half, and wow, look at the upgrade. An adolescent's mind can juggle complex problems, think strategically, and even multitask. To a point. That attention filter is now super precise, and the memory systems are running smoothly and efficiently. It's a night and day difference. So, Section 4. Why does any of this actually matter? What's the point of thinking about our brain like a computer? Well, it's because this whole analogy, it's basically the user manual for your own mind. Think about it. Once you know your working memory is tiny, you can stop trying to cram too much in when you're studying. You can be smarter about it. Once you realize that attention is a filter that you control, you can start actively managing distractions instead of just letting them pull you all over the place. This isn't just some abstract theory. These are real, practical strategies to help you learn better and, honestly, just think a little more clearly. And that really brings us to the big takeaway here. Look, we live in a world that is practically designed to hijack our attention and completely overwhelm our working memory. Notifications, ads, endless feeds. So the real question isn't just, is my brain like a computer? The real question is, how are you going to optimize your own operating system to thrive in it all? How can you become a better user of the most incredible computer you will ever own?